Hey coders, and welcome to episode 6 now of our utilities service playlist on the Google Apps Script course. In this lesson we're going to be learning about hashing and digital signatures, but before we continue I just want to give a huge shout out to the newest patron of this channel's Patreon page, Peter Weiss. Peter was able to subscribe to the Platinum tier, which means not only does he get a shout out in this episode, but also gets exclusive access to direct one-on-one email communication with me so that we can collaborate on his app script as well as Google Cloud and any other projects in which he is working on. Now if that sounds intriguing to you and you want access as well, then be sure to check out the Patreon page. The link is in the description. Now I also want to give a quick update on the microphone fundraiser. So we are currently at $135, which puts us at just $3 shy of our goal. And if we have $3 more, then we will be able to purchase that microphone to put on this channel. And then, so if you want to be on the special shout out list as well as help support the growth and future success of this channel, then be sure to check out that fundraiser in the GoFundMe link also in the description. Alright, so with that said, let's learn a little bit more about hashing and digital signatures. So both hash functions and digital signatures are somewhat of an unintuitive concept, so let's just reserve a little bit of time to give an overview of both of them. So hash functions are similar to normal functions in the fact that they take an input and then they output some output, but there are some key differences. And key difference number one, I just want you to remember that in terms of a hash function, the output is known as a digest. Okay, so just remember that word digest. Key point number two is that hash functions are a one-way road. So what that means is that they can only take an input and go from input to digest, but it is impossible, mathematically impossible, to go from a digest back to an input. And this is actually really cool if you think about this in terms of security. That means that even if you have that digest and you have the hash function that was used to make that digest, then you still are unable to re-engineer the input that made that digest. So that is really cool in terms of such things as storing passwords and other sensitive data within a database, even if that database is compromised and the hacker can see all of these digests. They are unable to re-engineer the original input that made those digests. So key point number three is that every single input has a respective digest. So every time I input the word, say, password, I am always going to get this digest on the right hand side of the screen. And if I change that word just by one character, then it will generate a completely new digest. And that just adds to the fact that you cannot take pieces of the digest and put together them to make the original input. That would be impossible. So one of the extensions or applications of hashing functions is digital signatures. So I'm not going to try to get too deep into the weeds of digital signatures. There are a lot of different ways in which you can create digital signatures. But just for the context of this video, let me explain digital signatures just so that we can get some understanding of it. So digital signatures are a procedure for verifying the identity of the sender of some message and the fidelity of that message which was sent. So let's say that there are two texters, Nathan and Bella, and Nathan wants to send a text message to Bella that is of the message, hey, with a smiley face. So when you send that message, or when Nathan sends that message, there is actually a lot of stuff going on underneath that message as well. So that message, as soon as he hits the send button, what will happen is that message will be hashed as well. There will be some digest that is outputted from a hashing function. It could be SHA-256 or any of the hashing functions. And then with that digest, Nathan, or at least the software on his cell phone, will contain both a private key and a public key. So what Nathan will do with that digest or his phone is that his private key, which is just a series of random letters and numbers, will hash the digest again to create something called the encrypted digest. And this encrypted digest is also known as the signature, and this signature is going to be sent along with the message, hey, with a smiley face, to Bella. And when Bella's phone receives that message, hey, then what Bella's phone is going to do is it's going to hash that message just like Nathan's phone did, but it's also going to take Nathan's public key and decrypt the encrypted digest. And so what that's going to do is it's going to make the original digest again. And if those two digests match, then we can be certain, or Bella's phone can be certain, that that message was indeed sent from Nathan and it indeed contained the message, hey, with a smiley face. Alright, I've already gotten too deep into the weeds of this example right here. So digital signatures, this isn't the only scheme of how digital signatures work, but this is a common one. And that is basically what digital signatures are used for. It's just to verify that the message is indeed coming from a specific identity or a specific entity, and the message is exactly what that identity or that person who sent it, it didn't get altered at all. So the top four methods which I have picked out for today are compute digest, compute HMAC SHA-256 signature, compute HMAC signature, and compute RSA SHA-256 signature. So let's decrypt these confusing methods in the code right now. One of the use cases of hashing functions is to encrypt and store sensitive data in a database without having to save it as plain text. So let's say that you are building out an application that is similar to this, and you give users the option to either sign in or sign up. But if a new user were to come to your website, they would definitely want to sign up. And then once they type in their email and password that they want to use for this application and hit this register button, then you will need to save that somewhere in a database. So for the simplicity of this demonstration, I have chosen the Google Sheets document, a Google Sheets document, as our database. So all that we're going to do basically is just store the email and password in this Google Sheets document row by row for every single user that signs up. So let's do that right now. So let's say a new user were to access our website. They would come in here and then they would type in their email address at sas.upenn.edu. Oops, I spelled it incorrectly. Alright, there we go. And then let's say that they choose the password as test1234 and then they register. Alright, so we have just been confirmed that we are now registered. Let's go and double verify that by going to our database, and there we go. We have now this user logged in to our or stored in our database, and here it is right here. But again, it's not really a good idea to now save their password as plain text in our database. For one, now whoever the database administrator can now see all of these passwords in plain text. So however many users that you have, they can now see all of the passwords. But number two, and even more importantly, is that if this database is ever, or if this Google Sheets is ever compromised, and hackers or people who aren't allowed in this sheet ever gain access to this sheet, they now have access to all of the passwords of all of the users that have signed up for your application, and that is not good publicity at all, and that is not good just in general for your application. So how can we encrypt these passwords before they land in this database? Well, let's first delete this right here and go back into our code editor. So let's take a look at the HTML code used to make this site right here. So here's HTML. I'm just going to be briefly scrolling through this just for the sake of time, and it's not really a web development or HTML and CSS course, but I am going to be uploading all of this to GitHub if you want a closer look at it, and always you can feel free to pause the video at any time to take a closer look at it. Alright, so here is now our client-side JavaScript. As you can see, it looks like we are adding an event listener to the register button, and then once that register button is clicked, then we are going to fire this callback function, which all this is going to do is just get the value of the email field of the email input, as well as the password input, and then store those two values in variables called email and password. And then we are going to run a server-side function called register, and then we are going to pass in that email and that password into that server-side function. So let's go back into our server-side code and look for that function, and here it is right here. It's right at the top, and as we can see, as we can confirm, all that this function register is doing is just appending a row to our spreadsheet, which is acting as our database, and then all the data that's going in that database is just the plain text email and plain text password that the user submitted in this form right here. So instead of just passing in the plain text password, what we would like to do is pass in some encrypted password, right? We want some encrypted password to be passed in instead of the plain text password. So how can we convert our password to an encrypted password? Well, to do that, we need to pass it in a hash function. And the method to do that within AppScript is found off the utilities parent class, and it is compute digest. So it is here, right here. So with compute digest, we need two arguments. We need an algorithm. So that's basically our digest algorithm that we're going to use for our hash function, and then also the input or the value that's going to be hashed. So in order to get all the algorithms that you can use, you need to go to the utilities parent class again and access the enum digest algorithm. So as you can see, we have access to 6 different algorithms, but generally, and you can use all of them, but generally the SHA-256 is a good accepted algorithm that a lot of people use. So that is what I am going to use as well. And then again, the value to be hashed, or the input to be hashed, is going to be our password. Alright, but if you remember from this method compute digest, what we are going to get in return is an array of bytes, and a byte array. And you can't really store a byte array that well in a database. What we would like to store instead is plain text representation of that binary, of that byte array. So if you remember from our last episode, we had a method called base64 that did exactly that. It would take a byte array and then encode that into plain text, into base64 encoded plain text. So that's exactly what we're going to use now again. So first let me just store this binary right here. First let me get rid of that actually. And then I'll say let SHA-256 equal this. Alright, so now this is our byte array in SHA-256. So then we need to encode that into our plain text. So the encoding scheme that we're going to use is base64, and if we remember from, again, our last episode, we go to utilities.base64 encode, and then we pass in our byte array. 256. Alright, so there we go. So now we have our encrypted password. First it's encrypted, and then it is base64 encoded, and then that is going to be passed in our database, which is basically our spreadsheet. So that's good for register, but we need to do something similar actually for this sign in process, which is found right here in this function. So basically, again, once a user signs in, we are going to receive their password in plain text. We are going to then pass that into a hashing function using the same algorithm. We're going to get the digest, and then we are going to base64 encode that digest, and then we are going to get our encrypted password, which we are going to verify is in the database. Alright, so now let me save this and see if this works. We will refresh this web application to capture any changes. We'll go to sign up, type in the same email, and then we'll choose the same password, test1234, and then we'll hit register. So now instead of this password going and being saved in the database, we should get now this password right here. And this is a base64 encoded representation of our hashing, of our hash functions encryption right here. So that is pretty cool. So now I can be pretty secure that if anyone were to come into this this database, this Google Sheet, they could see this password, but they would not be able to back engineer or reverse engineer my original password right here, test1234, with this encoding or this encryption as it is. So when you create a real application, you'll actually want to add something else in here. You'll want to add something called a salt before you compute the digest, before you pass it into the hashing function. But that is beyond the scope of this topic right now, and this is actually pretty secure as it is on its own. So I'm pretty happy about that right now. So let's see now if the sign in works as well. Again, if we type in just a character different, such as test12345, and try to sign in, then it says, sorry, you couldn't be signed in because this test12345 is going to be it's going to give an entirely different digest, which is going to be base64 encoded entirely different, and it's not going to match up with this password right here. But again, if we type in the correct password, then sign in, then there we go. We are now signed in, and we get that confirmation by being able to do something else with this pop-up right here. So that is hashing functions in action. So the second thing I want to do with this video again is digital signatures. So digital signatures by its very nature is something of a more complicated topic. As you can see, I already have a lot of code written out which I'm not going to be able to go over. But again, you can always pause, you can always rewind, you can always ask questions in the comments. But again, we're just going to do a simple demo with this digital signatures, and if you need any help, be sure to ask me in the comments below. Alright, so for this demonstration, we're going to utilize digital signatures through Zoom's API. So if we go back into our web application right here, we can see that we are presented with an appointment time. So what this web application does is you can sign into your account and then book an appointment or set up an appointment with me through Zoom after you click on a specific date and time, and then that will set up a Zoom meeting, and then it will create an event on my Google Calendar with that Zoom meeting with me and whoever signs up right here. So how can we do that? Well, we are actually going to need access to Zoom's API, right? So if we go into our server side again and we see create appointment, then we are going to need to create a Zoom meeting, which I had defined right here. And then it looks like we are going to use Zoom's API to get something called a Zoom user ID, and then we also need an access token. So if we go up here to get Zoom access token, it looks like we need to figure out how we can get this Zoom access token. So let's go to Zoom's documentation. Alright, so it says the Zoom API uses JSON web tokens to authenticate account level access. Alright, so that's good to know. So how can we actually make a JWT? Well, it says right here, generating JWTs. It says a single JWT consists of three components: a header, a payload, and a signature. So the signature they refer to right here is actually a digital signature. It's exactly what we are talking about in this episode, so that's pretty cool. So it says the header, payload, and signature with a period separating each. For example, AAB, C. So this is how the structure is going to be formatted. We got the header, the payload, and the signature. So let's see how to generate the header, the payload, and the signature. So right here it says header. This is going to be our header. We're just going to specify the algorithm. It says the algorithm that needs to be used is HMAC SHA-256, and then the type is JWT. So let's go back into now our code, and here we go. I have already declared that right here. It says header, and then here's our algorithm, here's our type, and then if we go back, here is the payload. Right here it says issuer API key, and here is the expiration timestamp. So I again have specified that right here. So this API key I have generated from Zoom's API dashboard. If you need some help in generating your own API and your own API secret, I'd be happy to make another video all on that, or maybe even answer some questions down in the comments below. But again, this is generated for me. So here is now our payload, and the last thing that we need again is a signature. So let's see how to generate the signature. It looks like we need to do the HMAC SHA-256 signature, and then we need to pass in the header and the payload and we need to sign it with the API secret. So let me actually just copy this right here. And then I'll say const, I'll say signature is equal to this right here. All right, but this actually is not a proper app script right here, right? So HMAC SHA-256 is not proper app script code right here. So we need a way to mimic this in app script. And the way to do that is to first access the utilities parent class and then say compute HMAC SHA-256 signature right here. So we could technically use this method right here, compute HMAC signature, right? And then what that will do is we'll need to specify a MAC algorithm, but since we are using the SHA-256 anyways, I'll just say compute HMAC SHA-256 signature. All right, and now we need base64 URL encode. So the app script equivalent of that is utilities.base64 encode websafe. We'll do the same thing now down here. And then that should generate our signature right there. And then we'll pass in the header followed by a period. And then we will do the payload and then a period. And then here comes the signature, just as it's specified up here. AABBCC right here, and then separated by dots. All right, so that should, if we have everything, let me take one more look. It looks like everything is good to go. So let me just save that now. And then I will refresh this page. So this right here, this Zoom access token is going to be again used when we create a new meeting with Zoom's API. And then we are going to now get that URL from our response. And then we are going to return that URL to our create appointment, and then we are going to paste that URL in the description of an event that we are creating, and then the guests are going to be whoever is making that appointment. All right, let's see this in action. So first we will sign in, and then we will use our password. We'll hit the sign in button. Alright, so here is our appointment. Let's specify a day that we want to do. We'll do it on Tuesday the 30th. And then the time, let's say that we want to make an appointment for 12 o'clock p.m. So we'll hit now this submit button. Alright, so we just hit the submit button and it says, congrats, your appointment has been scheduled. Let's see if that is the case by going to our calendar. And here we go. So now we have an appointment scheduled at 12 p.m. It says each appointment was only going to be 30 minutes long. That's exactly the case right here. And it says that we have an appointment with WeissJV at sas.upenn.edu. As you can see, we are signed into my David the Weiss 7 email address right there. But look at here, right here. So now this is the Zoom link that we just created. So if we say join Zoom meeting, it should take us to that Zoom meeting that we have just created right here. So there we go. I just clicked on it. I'm going to say now open Zoom. And here we go. This is the Zoom meeting that we just created. And just to verify again that this is a Zoom meeting, I am going to hit this button right here. And there we go, guys. This is indeed working. As you can see, this Zoom is indeed running. So let me just stop that and get out of here. And meeting. So that is pretty dang cool. If you ask me, we have just used digital signatures to communicate with Zoom API, and we have just created a meeting, and that has been put on our Google Calendar. And anybody now, or at least me and weissdava.sas.upenn, can access that Zoom link, and we can now communicate through Zoom. And all that was through a programmatic web app right here. So there's one more thing I want to do before I end this episode, and that is just talk about the RSA algorithm. So if you remember, we have utilities, and then we can compute an HMAC SHA-256 signature, or we can compute an RSA SHA-256 signature. So the RSA is somewhat similar to HMAC in the sense that they are both digital signatures, but they have a different scheme of operating things. So you would use the RSA signature. It basically has the same format. You would pass in a value and then also the key. But you would use, say, the RSA signature for something like DocuSign. So if you look at DocuSign developer APIs, you can see that their JWT is with the RSA SHA-256. So if you were trying to, again, access DocuSign's API, that is when you would use the RSA, and then you would just input the public keys or the private keys in this space that it says key right here. All right, that's all I'm going to do though. I'm going to end this video for now. I know this could have been a very confusing episode just because hashing functions and digital signatures are inherently kind of complex. But don't feel free to pause the video at any time, rewind the video, ask questions in the comments. I'm very happy to help answer a lot of your questions. But I hope you learned something from this. I hope you took something away from it. If you did, don't forget to hit that like and subscribe button, and I'll see you in the very next episode.